Please share,
Hello,
comment,
friends.
like, and
Good
follow
day.
for more
Once
chemistry lectures.
I am Dr. D.I. June, your lecturer on chemistry and social media. We are going to discuss today how to write a chemical equation. But in my previous video, I discussed on the meaning of a balanced chemical equation. I will touch a little bit of it, and I will enter this next one. Now, in a balanced chemical equation, you may see two arrows. One will be pointing up, one is pointing down. If you see an arrow pointing up, it means that a gas is evolved. If you see an arrow pointing down, that means it's a precipitate. Now, let us come into this topic, how to write a chemical equation. There are certain things you must know. You see, because in chemistry, we don't assume. We need a practicality. One, by writing the chemical equation, you must have known, one, the chemical symbols of the elements in question. What and what elements are combining? As we saw here, hydrogen is combining with oxygen to form water. So you must know what and what elements that are combining the reaction. Number two, you must know the symbols of the formula of radicals. Now, I give you some examples of radicals later on. Now look at it. What is a radical? By my own definition, a radical is an atom or a group of atoms that have a charge, either positive or negative, which can either react with hydrogen to form an acid or react with a metal element to form a chemical compound or a chemical formula. Now, these particular radicals could be either one atom of a group forming a compound. I'll give them to you now. Now these are radicals. Now this is an element, chlorine. This is trioxo nitrate 5 radical. This is trioxo carbonate 4 radical. This is tetraoxo sulfate 6 radical. This is sodium radical. This is ammonium radical. This is tetraoxo phosphate 4 or 5 or 6 as it may be radical. So, you must know this when you are trying to write a chemical equation. Now, examples I've given. Now, number two thing you are going to do is when these things are combining, what is the result? Because definitely, like for example now, sodium. This is called disodium tetraoxo sulfate 6. And because after knowing these symbols of radicals, then you must be able to know the oxidation number of the element. Now, what is oxidation number? This word, oxidation number. We call it ON. Now, in my local way of defining it for students to understand, is the combining power of elements. When elements combine, there is a degree or an extent of power that each of the elements that exhibits in that particular reaction. So, in a layman definition, oxidation number means the combining power of an element in a given reaction. Because reaction can take place either in acidic medium or basic, or a liquid or a gas. So the state of the elements or the state of the reactant also determines the oxidation number of the element. So you must equally know. And that oxidation number is called valency. Valency means the number of electrons in the outermost cell of an atom. Now, sodium has +1. You can see it here, +1. Chlorine, -1. Now, why is this so? A sodium atom is a metal. It has 11 electrons. So it has only 1 electron in the third shell. And that 1 electron, it either gives out or it receives more 7 from another one. If it gives out the 1, it becomes a noble gas. But with that one on top, it cannot get 7 from elsewhere to form a noble gas. Because the minimum electrons to be on the third shell is 8. And the maximum is 18. So, having known that, we must know the number of these elements. Like now, potassium is also K1. Potassium, K1 plus. Then calcium, 2 plus minus. Then we have aluminium, +3. Iron, we have iron 2, iron 3. Iron 2 is called the ferrous, so 2 plus. The iron 3 is called ferric, 3 plus. We have copper 1, copper 2. Copper 1 is called cuprous, +1. Cupric, +2. So you must have a knowledge of these issues concerning the elements and the radicals before you talk about writing a chemical equation. The number 40 you ought to know is you must know how to exchange and write the oxidation number of the radicals below and the right hand side of the symbol. Now, let me give an example here. See sodium, see chlorine here, -1. Sodium +1. So when sodium and chlorine are reacting to form sodium chloride, as it is here now, sodium chloride, it means the +1 of sodium goes to chlorine. The -1 of chlorine goes to sodium. So now mathematically, +1 minus 1 is 0. And that is why you are not seeing anything here. So that is NaC+. So, having known that, you must equally have to appreciate that the oxidation number of these elements are not there just for staying their sake. They are calculated to arrive at them. So that is going to be a topic on its own another day. Like now, if you're a chemistry student, sodium plus reacting with Cl minus to give you CaNaCl. That is sodium chloride element, the compound. Then we have magnesium, which is the 12th element. So 2 electrons at most set, so we have +2. So if magnesium reacts with chlorine now, the formula will be MgCl2. That means you are exchanging the oxidation number. The 1 of chlorine goes to magnesium. Magnesium 2 goes to chlorine. So you have capital M, small g, capital C, small l, then 2 as a subscript. Then if it is aluminium, aluminium is the 13th element on the periodic table. So we have 3 electrons in the atmosphere. So the ON of aluminium is just +3. These are the electrons that it can be available for transferring or for combining. So if aluminium is combining with chlorine now, chlorine has only 1 electron to be needed to form the compound. So when you exchange the oxidation numbers, the 1 of chlorine goes to aluminium, the 3 of aluminium goes to chlorine. So it will now look like now Al, then bracket opens, Cl, bracket closed, 3. These are the formulas of this. So before writing chemical equation, you must have a knowledge of these parameters, these principles. So by the time you are writing the chemical equation, you will know the direction you are moving to and the extent you are going to do. So, on the whole, I'm stopping there for the meantime. Please share this video, comment, and also follow me on my account for more content lectures.